Hello and welcome to May I AI. I'm Alexander Vacevik and I'm currently pursuing a master's in management.
I am Mustafa Al-Hayani and I have a master's in informatics with focus on AI.
And this podcast is a part of TUM AI, whose mission is to make AI accessible to everyone. This podcast is also part of the AI Academy, a series of workshops hosted by TUM AI at the Technical University of Munich. Each week we invite a different company to tell us about how they use AI in their industry. This week's company is NVIDIA, with vision transformers for industrial use cases. But first, let's clear up. What is computer vision, Mustafa?
Well, computer vision is the process of using computers to try to mimic how people do vision, right? And then there is a computer-based, a mathematical-based way of doing it, and then there is, of course, AI way of doing it. And we can we can divide them into three different methods, which classification, detection, and segmentation.
Can you explain to me these two methods? So let's start off with classification.
Well, classification is the easiest one, right? Let's say you have an image of a cats and dogs and you want to classify if the image you have is a cat or a dog. And then segmentation takes it a bit further, where instead of just trying to decide on the entire image, you're classifying every single pixel into one of the classes. And then object detection takes that a bit further, where you don't only want to know which object exists in the image, but you want to find all of them and you want to find where exactly they are in the image.
Okay, so computer vision is basically trying to find stuff in images on a very high level.
That is true, yes.
So then we know what computer vision is, but what are transformers? So I remember hearing this term transformer when talking about ChatGPT. How is that related?
Well, if you remember, GPT stands for Generative Pre-trained Transformers. And transformers actually started as a way to work on text. And this is why we've heard it before. And the whole notion, when we really talk about transformer, focuses first and foremost on the idea of what is called attention. And to pretty much understand attention, you can think of it as a teacher in a classroom. And let's say that every person in the classroom has something to say. But ideally, every student is important, but of course, sometimes some students say jokes and some students say stuff that are more important. And then the teacher's attention is divided across all of them. Now let's look at the students as words in a sentence. Not every word in a sentence carries meaning when it comes to whatever you're trying to classify. So for example, GPT, when it looks at your prompt, not every word and not every token makes sense to your context. And then it has to find out what words to focus on to answer or generate the proper answer.
So attention on a high level is trying to decide which data point in a vast array of data points is really important.
That is true, yes.
So you explained how attention works in natural language processing, where we look at sentences and which words are important. But how is that related to vision? I'm not really seeing the parallels here.
Well, how about we look at a very large image, right? We can try to give that to a model, and then the model is expected to focus on every pixel of that image, right? But of course, images can have parts of it that are important and parts of it that are not. So for example, if I'm trying to detect cars, looking at the sky makes no sense. Mm-hmm. And the same idea applies here, where attention would try to divide the image into smaller patches, and then the model will try to learn which patches or representation of patches carries the more weight when it comes to our context.
Okay. I think I can understand this now, but how does it help us with computer vision? Like, what is it making better about computer vision?
Well, in some cases, it makes the model a bit faster, but the most prominent feature of it is that it makes the model more efficient in terms of accuracy. Because now that the model is able to find more important objects when it comes to our context, it's able to identify the objects it needs to make its classification or segmentation and so on.
Okay. Thanks a lot. Can you wrap up computer vision and transformers for us one more time?
Well, like I said, computer vision is the way of trying to mimic everything that humans do when it comes to seeing and moves that to computers. And transformers are a way to add self-attention or attention mechanisms to our models. Vision transformers are a way to use both of these ideas to make our vision models more efficient.
Well, thanks a lot for listening to May I AI, and see you in the next episode.